We are going to explain section 4 from unit 6, section 4. The meaning of stoichiometric coefficient. Okay, what's the meaning of the stoichiometric coefficients? When we balance an equation, we write in front of each formula one number, and these numbers together are called stoichiometric coefficients. These coefficients are very important to understand how chemical reactions behave. They give us the proportions in atoms, molecules, and moles that react in the reaction. Let's get a simple example. For example, hydrogen plus oxygen to get water. I have to write in front of the formula of water 2 and then 2. These are the coefficients. When we don't write anything, it's because we have 1. Commonly, we don't write the 1, but now I'm going to write it to explain the meaning. So we have 2, 1, and 2. And these are the stoichiometric coefficients. What does this mean? This means that 2 molecules of hydrogen react with 1 molecule of oxygen to get 2 molecules of water. But what if we don't have just 2 molecules? We have a lot of molecules. For example, 2 moles of molecules. The proportion is the same. 2 moles of hydrogen reacts with 1 mole of oxygen to get 2 moles of water. Why do we write moles instead of molecules? Because the proportion is the same. And now we can translate this to grams using the formula mass equals number of moles times molar mass. I remind you that the molar mass, we get this number from the periodic table. Okay, so if we go to the periodic table, we find that the molar mass for hydrogen is 1 and for oxygen is 16. So 2 atoms of hydrogen have molar mass of 2 grams per mole. The molecule of oxygen is 32 grams per mole, and the molecule of water is 18 grams per mole. I'm going to write this number on top of the substances to have it for the rest of the explanation. 2 molar mass equals 32, molar mass equals 18. I get this, I remind you, from the periodic table. So now, if I have 2 moles of hydrogen, applying this formula, I get that the mass is 2 times 2. 2 moles times 2, which is the molar mass of hydrogen. So we get here 4 grams. If we do the same with the mole of oxygen, mass equals 1 because we have 1 mole times 32. So the mass is 32 grams of this mole. And now the mass of these 2 moles is 2 times 18. So this gives us the result of 36 grams. So as you can see, if we add the 4 grams of hydrogen plus 32 grams of oxygen, we get 36 grams in the reactants and 36 grams in the products. So as you can see, this is Lavoisier's law. Okay, because the total mass hasn't changed during the reaction. Why? Because no atoms have disappeared. They have just been rearranged. Se han reorganizado. Okay? The total mass does not change during a chemical reaction. But going back to the example, we have these stoichiometric coefficients. And I said that these coefficients show the proportion of molecules that react. So molecules or moles. So 2 moles react with 1 mole to get 2 moles. But what if I have double? For example, if I have 4 moles of hydrogen, how many of oxygen do I need to react with 4? Well, it's just the proportion. If 2 need 1, 4 need 2. And how many moles of water will we get? Well, with 2 hydrogen moles, get 2 with 4, 4. And we can do the same with all the numbers. Imagine I write here 20 moles of hydrogen react with 10 mole of oxygen and we get 20 mole of water. So the proportion is always the same. And we will use this proportion to solve examples. For example, imagine that they ask us, how many moles of water do we get if 3 moles of oxygen, I will write the numbers here, how many moles of water do I get if 3 moles of oxygen react with a lot of hydrogen? We don't know how many, but I don't need this number because I can do the proportion with these 2 substances. So I get the data that we have from the stoichiometric coefficients and I do the proportion with these numbers. 1 mole of oxygen, with 1 mole of oxygen we get 2 mole of water. So with 3 mole of oxygen we do this proportion is 3 times 2 divided by 1, so we get 6 mole of water.